Hi, welcome to another video. So in today's video, I wanted to actually address one of the common misconceptions on microservices. So I've often heard, especially in interviews, people saying, hey, we use microservices, or why would you use microservices? It's just so I can scale the application, handle more requests per second and all of that, performance reasons. And so on, all of the companies which use microservices actually use them for performance reasons. This is actually plainly not true. Right? That is not the reason those companies like Microsoft and Uber and Netflix kind of use microservices, right? But they all do. And the reason really is organizational. So the reason boils down to Conway's Law, which kind of Conway in one of the papers, I believe, he mentioned that organizations which design systems, right, are constrained to produce designs which are copies of the communication structures of these organizations. So what it really means is, it really means that the way you talk to other people in the company, this will, at the end of the day, influence or guide the design of your code, right? So as in this XKCD kind of comic, you have like companies like Apple, or you used to have Steve Jobs and like now Tim Cook, right? In the center of everything. So Steve Jobs was in the center of everything and a lot of decisions in Apple. Right, when you have Microsoft, different teams creating competing products, and then you had several products doing essentially the exact same thing and have internal competition around it. So it really is this organizational communication patterns influencing code. So microservices is really about how can we design software which scales with teams as opposed to software just born out of process, right? So let's kind of look at this Conways Law in practice. Let's say there's two engineers working on a piece of code, and as two engineers, they know exactly what the other is doing. They can review each other's code. Things go really fast, right? They can understand the velocity is high. But as more engineers, as project grows, more engineers are added to the project, more difficult it gets to get things done. Slower it gets to get things done, honestly, right? Because now you have to synchronize many people together, more meetings, more communication, right? And larger it gets, more difficult it gets, especially on architecture. It becomes messy, there's redundancy, there's kind of tech debt which accumulates, and this is what really happens, right? If, like, for example, you work on one piece of code and you throw 50 people, things will get very, very slow. So let's kind of address actually a few of architectural patterns. There's a few of them, really. There's just kind of major ones. So most projects begin with monolithic architecture. I mean, for example, I'm building a service. It's going to be one big thing, one big code base, maybe even one big process which gets compiled, right? And it's correct. It's the right way of doing so, right? Because when you start with a project, you typically a small team, right? You typically don't need any microservices or even service-oriented architecture for that matter, right? Because microservices at its core is so you can scale a team, right? So you can work on the same product with 100 engineers, 1,000 engineers, 10,000 engineers, right? So, for example, companies like Uber, right, Yandex, they work on basically on the same type of product. There's 1,000 engineers working on the same thing. So it's really about how you scale the company more of like performance of code. It doesn't really matter. You can monolith really, really fast and really, really scalable and distributed and all of that and handle. hundreds of thousands requests per second. So let's kind of go through each of them quickly. So monolithic architecture, typically you have kind of one server, you have modules inside, right? You might have a database, so you have 2-tier, 3-tier architectures, but typically it's monolithic, right? You have one application server, and it's self-contained, right? So you can have modules, and the modules typically have contracts. If you really well designed, you actually can scale this architecture pretty well. You can have hundreds of engineers working on the same thing, as long as they don't work on the same module. It's well separated, right? It works very well. Then in history we had this service-oriented architectures, when we kind of thought about, okay, let's do the service thing. Let's have different teams defining contracts. So breaking up the monolith in services, really. So teams have different contracts between them, right? And then there's some foundation on the bottom, right? And that's typically called enterprise service bus. And thing is, a lot of business logic kept leaking into the enterprise service bus. And at the end of the day, that became your application. So kind of been a lot of mistakes in different companies, and it's kind of been back. Now your monolith is your enterprise service bus, and well, what's the point of service-oriented architecture, right? And the problem was really that the enterprise service bus was too of a big thing, too of a complex thing. So microservice architecture takes it, okay, how about this service thing works, so how about we actually go and remove this enterprise service bus? We just make every service separate entity, and then they can communicate with each other through things like gRPC, HTTP, or publish subscribe methods, right? It is dumb pipes, not anything super smart, right? And then each service would have a business-oriented capability, right? For example, you might have a pricing service, you have a booking service, right? And then a subset kind of services you'd have on infrastructure. So you have a monitoring service, service discovery, so and all of that, right? And that really worked well for those big companies, because now suddenly teams can be completely separated. They are well-defined contracts which they cannot break, because they will actually it's enforced by code, right? And they can scale this team. They can add more business capabilities, have more teams kind of responsible for those business capabilities, growing them independently, maybe even different languages, programming languages. You don't care, as long as the contract remains the same, right? Communication, even personal communication, becomes simpler, because you now only need to agree on the API layer. So let's say in the project I'm working on right now, there's 2 teams involved, and the most of communication happens in the beginning when you kind of try to agree on the API, right? In API, other team need to provide to you, or you need to provide the other team, right? And once you agree on that, whatever is the actual business logic or in fact implementation, you don't care, right? And most likely you're not going to even look at it. And that is what's really important. And that is the power of microservice architecture, is scaling the team, making your organization grow from 100 engineers to 10,000 engineers, right? How do you do that? So coming back about on this 3 types of architectures, well, monolith is very works well for small teams, but it has tight coupling, right? Because it's difficult to enforce that people actually use modules properly. Typically doesn't work right, with business deadlines and things like this. And developers must agree on each change. right? And then maybe unanticipated effects if they take dependencies on things they shouldn't, right? Or there's modules, the architecture is not that clean, things like this. Then the service-oriented architecture, it's getting there, it's developed autonomously, right? But there's still some coordinated fit overall design where the enterprise service bus comes in. And microservices is really kind of this completely decoupled. We just have those interfaces, and you can use whatever microservice in the company you want or you need. Like, it comes with other problems, which I will discuss in other videos. But let's just scale the team even higher. So that's it. In the next videos, I also want to talk about kind of more deeper on microservices. And if you have any questions, please firstly subscribe and then leave any questions in the comments below. Thanks.